Okay, so this unit 11, redox. Redox is a portmanteau of reduction and oxidation, meaning two words stuck together. So reduction and oxidation. So we're going to learn about oxidation numbers, where they come from, and how they are changed. I'll also talk about oxidation and reduction being a transfer of electrons. There's two terms here you need to know about: is reduction and oxidation. Reduction means you gain electrons. Oxidation means you lose electrons. Well, let's start by looking at this first warm-up right here. Explain what's happening to copper in this. Well, in copper and iron, if you look at it, iron starts out all by itself. So iron is here, and the oxidation on iron, charge on iron, because it's an element all by itself, would be 0. Afterwards, iron is now in a compound. It's in a compound, and the sulfate, remember the sulfate anion, SO4, that's a 2 minus anion. So therefore, iron must be an Fe with a +2 charge. So similarly, copper starts out with sulfate, so that must be a 2+ charge. So Cu starts out as a 2+ charge, and then at the end, Cu is all by itself. Cu being all by itself has an oxidation number of 0. Well, what's happening here? Well, what's happening here is both an oxidation and reduction. Oxidation, as it says up here, oxidation means a loss of electrons. Reduction means a gain of electrons. So we look at this in terms of electrons. What's happening? Well, the electrons. Well, if we look at our first equation here, iron, in order to make this thing neutral on both sides of the reaction, we would have to add electrons. Well, where are we going to add electrons? Well, the electrons would have to go on this side right here, on the product side. So now we have a 2+ ion being added to a 2- electrons, makes it neutral over here. The same thing is happening on the other side of the next reaction. Copper is gaining 2 electrons, and in doing so becomes neutral. So in this first equation, this is considered an oxidation reaction. That's oxidation because iron is losing electrons. Whereas the second one down below here is a reduction reaction because it is gaining electrons. Now it sounds kind of counterintuitive, reduction gaining things, but if you look at the oxidation numbers, let's look at just the oxidation numbers here. All right? Oxidation number of copper is a 2+ here. Well, over here, they went to 0. Is it going up or is it going down? Well, that's going down. So that is reducing the oxidation number. Whereas the iron's oxidation number goes from 0 to a +2. So its oxidation number is going up. So going up means oxidized, going down means reduced. That makes more sense intuitively. There are 5 rules. The 5 rules here have to do with assigning oxidation numbers. And here they are. Rule 1. Any element by itself is going to be a 0. Monatomic ions, the charge of the monatomic ion, that is what it is. So if it's a Cl minus, Cl it's -1. Oxygen is almost always -2, except for the peroxide ion. There's only a couple of cases where that shows up. Hydrogen peroxide and sodium peroxide. And hydrogen is almost always a -1, or it should be a +1, unless it is a more electronegative element, like with a metal. And the 5th rule is the halogens are always -1, unless they're paired up with oxygen or fluorine. So let's look at a couple of these equations. So copy those notes down, and then continue on. All right, so here's a couple of equations, couple compounds. Remember, compounds must be electrically neutral. So this first one here, sodium chloride, well, we know this one's because it's chloride here. We know that chlorine, according to rule 5, is a -1. And sodium, because it only has one oxidation number, monatomic ion, it's got to be a +1. So +1 -1, that makes that a neutral compound. The second compound is not a compound, but rather a polyatomic ion. It's hypochlorite ion. The whole thing has to add up to a negative 1. So if we take all the ions, the atoms in ions, they have to have negative 1. So we have a chlorine added to an oxygen. Well, according to rule number 3, oxygen is almost always negative 2 unless it's with peroxide, and this is not peroxide. So we have one oxygen, which is a negative 2. Then chlorine. Well, chlorine must be, in order to make that thing balance, be a positive, or to be a negative 1. Chlorine's got to be a positive 1. Positive 1 minus 2 is negative 1. So that's the oxidation number of hypochlorite. In the next one, we have chlorite. In this case, it's also equal to negative 1. But now we have 2 oxygens, and we have 1 chlorine. Well, again, oxygen's almost always a negative 2 unless it's with peroxide, and this is not peroxide. So we have 2 negative 2s. And this time, chlorine's oxidation number is going to be a plus 3 to make that work out. In the sulfate anion is in charge of negative 2. So we have a sulfur being added to 4 oxygens. Again, oxygen is almost always a negative 2. So 4 times a negative 2 is negative 8. We already got to maintain a negative 2 charge. Has to maintain a negative 2 charge. So in this case, sulfur has to be a positive 6. So those are the oxidation numbers of different elements inside a compound or a polyatomic ion. It says it takes 2 to tango. What that means is you must have an oxidation at the same time you have a reduction. We did this one earlier. When we looked at this earlier, we saw that iron oxidation number goes from 0 to plus 2. That is being oxidized. Copper going from plus 2 to a 0. Right here. Iron goes from 0 to plus 2, whereas copper goes from plus 2 to 0. You can't have one without the other. In order to have one thing, you must have the other one. Alright? The way to help you remember this is 2 mnemonic devices. Leo goes GER. L-E-O. Those stand for loss of electrons and oxidation. GER stands for gain of electrons and reduction. There's another mnemonic device called oil rig. Again, we're talking about electrons being gained or lost. And oxidation, O-I-L, is oxidation electron is lost, and reduction electron is gained. And copy those down. So here's a couple questions. Go through this question. So in this problem, we're looking for carbon to have an oxidation state of negative 4. Well, the first one with carbon monoxide, you have a carbon plus oxygen being 0. So oxygen is going to be a negative 2, so therefore carbon has to be a plus 2. That's done there. In carbon and fluorine. Chlorine is going to be a negative 1, so you have 4 negative 1s. So therefore carbon has to be a plus 4. So that's done. Carbon dioxide. Oxygen is going to be a negative 2, so we have 2 negative 2s. Each carbon must be a plus 4. And then the last one is CH4. The hydrogen is a plus 1, so we have 4 plus 1s, so therefore carbon has to be a negative 4. So there's your answer. CH4 carbon is a negative 4. Take a look at this one. Alright, in this one, we're looking for the species that is oxidized. First of all, get rid of the things from the product side. So this is not oxidized, and this is not oxidized. So you get rid of those right away. After 0, that's gone. Al3+, that's gone. We're only considering the things that are on the reactive side. Those are the things that are oxidized or reduced. Okay? So we have to look for an oxidation number who's going up. Well, aluminum's oxidation number goes from 0 to plus 3. Is that going up or down? Well, it's going up. So therefore, aluminum is the species that is oxidized. Iron goes from a plus 2 down to a 0. That's going down. That is reduced. So the answer must be number 1. Number 3, oxidation of chromium in this one. This compound has 2 potassium, 2 chromium, and 7 oxygen. The whole thing must add up to 0. Potassium is a plus 1. Chromium we're looking for, so oxidation number of chromium in this compound is plus 6. Okay. Same idea.
This week, I believe.
You have potassium, iodine, and chlorine. All must add up to 0. Potassium is plus 1. Iodine is unknown. Oxygen is 2. Sulfur X. Iodine's oxidation number in sulfur X is plus 6. Number 5, in an oxidation reaction, reduction is defined as the gaining of electrons. That's just the definition, the gaining of electrons. Number 6, the lithium atom forms lithium ion. The lithium atom goes from Li0 to Li plus 1. It must lose an electron to do that. That's what it is, losing an electron. Particles gained and lost during redox reactions, by definition, it's electrons. 8, calcium undergoes oxidation from calcium 2 plus. Number of neutrons remains unchanged because oxidation reduction has nothing to do with neutrons. In a redox reaction, the reactant can undergo a decrease in oxidation by number by. The only way you can do that, decreasing its oxidation numbers by gaining electrons. An atom of nitrogen gains electrons, oxidation number will decrease because you're gaining negative particles. The reduced reaction, which is reduced in the reaction below, again, first of all, get rid of the things in the product side. Aluminum over here is plus 3, get rid of that. Aluminum over here, copper over here is a 0, get rid of that. So you have your choices of aluminum, copper, you have your choices of copper, sulfur, or oxygen. Well, notice that sulfate stays together here, and it's together here, so that's remaining unchanged, so therefore the answer has to be copper. Copper goes from a plus 2 ion to a 0 over here. The oxidation reduction that occurs. What's going on here? Look at it carefully, figure it out. Well, cobalt goes from a 0 to a plus 2 here. Lead going from a plus 2 to a 0. So cobalt oxidation number is going up, so it is being oxidized. Lead's oxidation number is going down, so it is being reduced. The answer is 2. Cobalt's being oxidized, lead's being reduced. Lead 2 plus is being reduced. Which one shows reduction? Reduction, remember, means gaining of electrons. Automatically, we can get rid of number 1 because it's not gaining electrons, it's losing electrons. As is number 2, that's losing electrons. 3 and 4 are both gaining electrons, but one is done correctly, one's done incorrectly. Here, number 3, we have a 0, negative 2, plus 2. That does not equal it. But a plus 4, negative 2 equals plus 2. There's the one that's done correctly. An oxidation reaction. First of all, in these kind of reactions, get rid of your double replacements. Double replacements are definitely not. So there's a double replacement. The bottom one is a double replacement. Now, what you're going to do is you're going to look for oxidation of your single replacements. Single replacements, they are redox reactions. But we don't have a single replacement. The next trick is to look for something, an element that is by itself on one side and in a compound on the other. And then what we see over here, chlorine is in a compound. Over here, chlorine is all by itself. So those are your rules. So those are the rules. Look for a single replacement reaction. And then we look for an element, a compound on one side, and then by itself on the other. Same thing here. Rules again, hold fast. Look for single replacement reaction. See a single replacement reaction? If so, that is a redox reaction. Right away, see here, magnesium is taking the place of hydrogen and pushing hydrogen out. So there's our single replacement reaction. That is our redox reaction. Number 2 is a double replacement. Get rid of that. Number 3 is just a reaction. Not even a reaction. It's just the dissociation of magnesium hydroxide. And this last one here is just the hydration of magnesium chloride. So